So for this video, we're gonna talk about Newton's law of gravitation, and then we'll review practice problem number 24. So the first thing we're gonna do is just talk about Newton's law of gravitation, which I'll write out real quick. So m1 m2 over r squared. So this is just saying the force of gravity between two objects is gravity times the mass of the two objects divided by radius squared, which is the distance between the two objects squared. So this equation is going to come up a lot, especially when there are problems that deal with orbits and masses in space and stuff like that. So now I'll get to the problem because it's going to take a long time. So the problem is a three-part problem. I'll show the diagram real quick. So it's two different satellites that orbit with two different radii. So M1 has R1, M2 has R2, and it's assumed that the mass of the planet at the center is greater than both mass 1 and mass 2, and mass 2 is greater than mass 1. So now we're going to look at the problem, which asks the ratio of the speeds v1 over v2 is blank. So to solve this problem, we're going to start with our equation from Newton's law of gravitation, and then we can, for force of gravity, we can simplify it, so it'll end up looking like this. So Fg equals m2 So we're going to cancel out that. We're going to sub in MA for FG and then cancel out the M2s on each side. So that'll look like this, like that. And then we know that A is also equal, centripetal acceleration is equal to V squared over R. So now we can simplify this even further. So it's going to be GM1 over R squared equals V squared over R. We can cancel out the R's, so that and that, so it's just going to be V squared equals GM over R. We have that. So now we're going to plug in V1 and V2 from our diagram into this. So it's going to look like this. So V1 squared equals GM over R1, and V2 squared equals GM over R2. So now what we're going to do is we're going to solve for GM, which is in both equations. So we can rewrite these as V1 squared R1 equals GM, and V2 squared R2 equals GM. So therefore we know that V1 squared times R1 equals V2 squared. R2. So what we're gonna do now is we're gonna make this into what the problem asks, which is the ratio between V1 to V2. So if we do that, we divide by R1 on this side, divide by R1. So we can say divided by R1, and then we're also going to divide by R2. So that's going to make it look like this. V1 squared over R2 equals V2 squared over R1. So now we can see this, and so we'll divide like this, so we get the V's and the R's, the V's on the same side. So it'll look like this. V2 squared over V1 squared. So we get that on the same side. And then, of course, to find this, these are squared right now, so we have to take the square root of this, which is just like taking the square of the top and the bottom. So the answer is gonna be, oops, I forgot to flip this, so we can just reverse these. So it's gonna be R2 over R1 equals V1 squared over V2 squared. So we take the square root of each side, right? Then we finish with R squared of R2 over square root of R1 equals V1 over V2. And that's the ratio of V1 to V2, which gives us root R2 over root R1, which is answer A. So that's answer.